Okay, respiration. For respiration, I would remember your ventilation pressures. So I would remember the ATM, the atmospheric pressure, is always 0 when we're talking about the pressures of ventilation. The alveolar pressure needs to be -1 or +1 because we're talking about movement of air. For air to move, there needs to be a difference. So during inhalation, it's -1. Typically, when we're exhaling it's +1. For our pleural pressure, that is going to be -4. That is the pressure that's pulling against the lungs so they don't collapse. Remember, there's fluid there between the ribs and the alveoli within the pleura that are maintaining a constant pressure so the alveoli don't collapse automatically. We can calculate a transpulmonary pressure, which is the difference between the two. That changes during inhalation and exhalation. As we inhale, the transpulmonary pressure decreases. It goes from -4 down to about -6 or 7, and that allows air to come in at a higher volume. During exhalation, that decreases back to -4 as we push the air out. I would know the reason for surfactant, what it is, what it does, why it's needed. So surfactant, remember the law, or Laplace's law, there are different sizes of alveoli. The larger alveoli without surfactant would overfill, while the smaller alveoli would collapse. That would be some serious issues. So with surfactant, we equalize that pressure, both fill to their maximum potential, and we can breathe normally. I would also know what is given to a mother if she were to go into preterm labor. About 34 to 35 weeks, babies begin to produce their own surfactant. Prior to that, they don't have any. They would struggle with breathing. So if we know a mother's going into labor, we will give her corticosteroids, and that increased stress hormone causes the baby to start producing its own surfactant. So when they're born, they have some surfactant on board, which helps with breathing and long-term outcomes. Further, I would know what a pneumothorax is. That a lung collapses, that's what we call a pneumothorax. I would know what causes that. Perhaps a leaky lung, so the intrapleural space begins to fill with air, and the lung can no longer maintain air, so it collapses. I would know tension pneumothorax, any of those. So further, I would know what Fick's law is, how that affects the transport of air across the membrane, right? So Fick's law, the first principle is the thickness of the membrane affects the movement. Second is the coefficient of diffusion. I would also know the third one, which is the surface area of the membrane. And fourth was the partial pressure differences between the gases. Remember those four and how they apply to the movement of gases within our respiratory system. I'd also freshen up on Henry's law and how that's applicable in the respiratory system. If you remember, Henry's law is the coefficient of solubility times the gas pressure. So if we have something that is super soluble in a fluid, then we don't have to put as much pressure on it to dissolve in the fluid. We can relate this to oxygen and CO2 within the body. Oxygen has a super low coefficient of solubility. It does not dissolve well in the blood. So we have to increase the pressure, and that is reflected in pressure that we'll discuss later. But CO2, to have the same amount of CO2 dissolved in the blood as we have oxygen, takes far less pressure because it has a higher coefficient of solubility. We'll discuss that further when we discuss the pressures of ventilation.